good morning, friends. I hope you are all doing very, very well this fine first day of May. So, happy May 1st. I hope May turns around and brings us things like getting out of our houses. So, I miss you all, and I hope you are all doing well. And yes, as you can see from the title of this worksheet, we are preparing for the Unit 7 test. So please, I'm making this video to show you step by step how I want you to do each question. There's also going to be problems where you explain your steps. So this video is going to be extremely important for you because it's going to give you the language and the examples that I expect to see when you answer those kinds of questions. So I'm going to show you how I would expect you to answer a question like explain your reasoning, explain why you thought that, explain. So there's going to be a lot of explanation in this video, and it's going to be really, really important that you understand that that's the part of the test that makes it that so that you can't cheat. Yes, you could watch this video over and over again, but that piece where you're writing in sentences, explaining your thinking and explaining why it works is the part that kind of makes a difference. So, first thing to keep in mind, remember this is exponential and logarithmic functions. And it started the unit with an equation. We kind of went at it by graphing first, but there's an equation, P times, parentheses, 1 plus or minus R divided by N to the NT. Sorry if you can hear my dog licking her feet. My Zenna. Silly dog. Okay, so what does this mean? This is where it starts. And we can use this for anything. 1 plus or minus the rate. This is how many times we compound it. So if it's compounded twice a month, if it's compounded once a week, if it's compounded once a year for 10 years, but the rate stays the same, we don't have to do this. Well, we would do it for 1. But this is how many times it's compounded. So times it's compounded. So if you guys remember, we started with the viruses growing. This would be kind of, hey, does yours grow does yours double every 12 hours compared to someone else's who doubles every 6 hours? So that's what this piece right here is. This is also the times it is compounded. The T is the time. Always in years. So let's look at this in kind of practice. You have inherited land that was purchased for $30,000. That is the P where it starts. So $30,000 is our P. And it was purchased in 1960. The value of the land increased. So because it's increased, it's going to be a plus. by approximately 5% each year. So that's going to be our rate. And remember, we changed that to a decimal by doing either dividing by 100. I, as everyone knows, like to call it booty cheeking it to the left 1, 2 places. Okay. What is the approximate value of the land in the year 2011? Okay, so is this being compounded multiple times each year? Probably not. So it is simply going to be, because it's compounded only once a year, we're just going to put the R, because anything divided by 1 is itself, right? And 1 times the time is going to be, the time. Okay, so we have $30,000, that's our rate, times 1 plus 0.05 to the, and it says to the T, how many years is this? So that's the biggest trick. We can't put 2011 and we can't put 1960. We actually have to do some math here. We have to determine 2011 minus 1960 and figure out how many years that is. And it should be 51 years. So our T becomes 51. So then you go to your Desmos graphing calculator, or Desmos calculator. Let's see if I can, okay, there we go. And we have 30,000 times, and remember it was 30,000 times, we could put it in parentheses, 1 plus 0.05, close our parentheses, add our exponent, and it's 51 years. Now that means it is worth, it started at 30,000, it's now worth $361,223. $361,223. That's it. Now, the explaining part, the part that I want you to be able to explain. I want you to be able to explain all of the numbers and where they went into the equation. So, I want you to be able to say something like 30,000 is the P because it is the starting amount, starting value of the land, and P stands for principal. Which is the starting amount for an account. I used information from the problem and the definition of principal in order to explain it. You could talk about rate. So a percent is equal to a decimal by moving the decimal two places to the left. which is why the rate used is 0.05, sorry, and not 5%. We add this to 1. Because the value is increasing. And the exponent is the time. That is explaining how you did the problem and why. And so you would write something similar to this on any of the questions that ask you to explain the steps. Very similar to this. Explain where the numbers came from. Explain the definition. If you end up using these word for word, I think that's a little weird, but anyway. So I certainly hope you have no questions about that. But that's what you need to do. Okay, let's look at question number 2. An adult takes 400 milligrams of ibuprofen. That's not very much. Each hour, the amount of ibuprofen in the system decreases. Okay, so 400 is the starting amount. So the P equals 400. Each hour, the amount of the decreases. So it decreases tells me I'm going to subtract from 1. So we are going to take 400 and we are going to do 1 minus. Now the rate is 29%. So instead of having the percent sign, again, I booty cheek it to the left or divide by 100. That becomes 0.29. How much ibuprofen is left after 6 hours? Because it happens each hour, that means once per hour, I would divide the rate by 1. I don't have to worry about that because it's only compounded the 1 time, and the time becomes 6. Now, originally I said, hey, the time has to be in years, and that would normally be true, except for in this case, we're talking about hours here, we're talking about hours here. So, this is our problem. I've explained where each of my numbers come from. Then you go to the calculator and hit clear. So 400 times parentheses 1 minus 0.29, close our parentheses, go to our exponent, and it's 6 hours. So you should see that there is 51 milligrams. How much ibuprofen is left after 6 hours? 51 milligrams. Approximately, because I rounded. Okay. Next question. You deposit $1,600 in a bank. Find the balance after 3 years if the account pays 2.5% annual interest compounded monthly. So this is a situation where we have to take our rate, 0.025, and why is that our rate? Our rate is this because, remember, we have to booty cheek it 2 places to the left, 0.025. And this time, we're dividing it by how much it's compounding. It's compounding monthly. Now, if it's paying you, find the balance if the account pays you. That means we add it to the 1. And it starts with 1,600. So that is our starting amount. And it's 3 years. But remember, we have to multiply that times how many times we compound it. So this is going to be 12 times 3 because we are going to actually compound it 36 times. Okay, so again, the difference in this question is it's saying that it's compounded monthly. So I have to take my rate and divide it by 12 because there are 12 months in the year. Remember, this is the part where you're going to be explaining. Our time is going to change because we have to multiply our years times 12 because that we have to take into account that it's compounding every month for 3 years. It's paying, so we are adding it to the amount. That's all you really need to explain. And you would write that out in sentence format. Okay, let's go to the calculator. So, 1,600 times, and it was 1 plus, I'm going to add another set of parentheses, because I don't want it to, I know it follows order of operations. I don't want it to be a problem. I have to hit arrow over to close my parentheses. Okay. So we have this, and then we do to the exponent of 36. Where did the 36 come from? Well, that was 12 times 3. All right, so you should have $1,724.48. 1,700, how much? $24.48. Okay. Your baby brother has an ear infection. The doctor said there are probably 50 million bacteria in his left ear. The penicillin the doctor prescribed will kill, so we know that the word kill tells us we are going to subtract. 7% becomes 0.07 of the bacteria every hour. How many bacteria will be in your brother's ear in 1 day? So it says every hour. So we're going to be compounding it every hour. But we're actually not compounding it. We're simply going to be doing 50 million times 1 minus our 7%. Because it says that the 7% is constant. Here, when it compounds it monthly, the bank doesn't want to pay you 0.25% over every single time. They want to pay you that for a total annual interest, which is why we divided it by 12. Here, it's going to be 7% every single hour. So we have to keep the 7% the same, and we're going to do it for 24 hours. All right, let's go to our calculator. Okay, so 50 million, 0, 0, 1, 2, 3, 1, 2, 3, times, parentheses, 1 minus 0.07, exponent, and 24 hours. Now, something to keep in mind, if you aren't practicing putting in these exponents, putting in the calculator, you're going to potentially get something wrong. You should be opening up Desmos and practicing pushing the buttons as I'm pushing them so that you know how to do it on the test. If you're just watching or listening to something else at the same time, I've seen my daughter do it, let's be real. She'll have her video playing and then she's having a conversation and watching a video on Snapchat or TikTok or whatever, and eating her sandwich all at the same time, thinking that she's paying attention. She's not. You've got to actually engage in the learning, practice putting it into Desmos, write it down on paper. Okay? This is a different way of learning, guys. Okay. So there's going to be 8,761,143 bacteria in his ear. All right, let's move on with this test. So these are the kinds of questions that you're going to have to explain. I'll tell you if there's more. Just wanted to let you know. All right, so let's keep in mind that it's growth when the base is greater than 1. It's decay when the base is less than 1. And so the base is always going to be, if it's decay, it's going to be either a fraction or a decimal that is less than 1. So we call this the B, the base. So when the base, the growth is greater than 1, so when the B is greater than 1, it's growth, and when the B is less than 1, it's decay. So here is the base. The base is 1/3. 1/3 is a fraction. That means it is decay. Here is our base. Our base is 2. In fact, we could rewrite this as 1 times 2x plus 1. So it starts at 1. Okay, 2 is a number greater than 1, so it is going to be growth. This says it starts at 1/4, but the base is 3. That means it is going to be growth. And again, this is where it starts. It starts at 4, and it has 1/2. This is our B. That is going to be decay because it is less than 1. Questions on that? Certainly hope not. Okay. H and K and determine the domain and range. Okay. I'm not really going to ask you to identify the H and K. What I will suggest that you do is use the graphing calculator to check your answers. But what I want you to notice is that you can determine this all on your own. Okay. This plus 2 tells the y, because it's, I can subtract the, here, let me show you. Right now, I can easily subtract 2 from both sides, right? That means this 2 actually goes with the y. Okay. So this 2 changes the y. It changes it up and down. So it moves it 2 places. And it moves it, because it is positive, it moves it 2 places up. So we now have a new horizontal asymptote. Then it says the x is -1. So it moves our x value to the right 1. The x value is always the opposite. So it's going to be moving it to the 1 and draw it kind of like this. So once I draw this, I can see, and I'm so sorry, it's bad, but that's all right. My x values, it's going to go on and on and on and on and on and on and on forever. So my domain is going to be all real numbers because it goes all the way to the left and it will go all the way to the right. My range is going to be anything greater than 2. The y is greater than 2. That's all you do. Okay, so this is going to be a decay. How did I know it's going to be decay? Because this number right here is less than 1. Okay, now I could actually have a plus 0 here. So it means that I'm going to not move from my y-axis. I'm not changing my y at all. So here is my horizontal asymptote. And from that point, it moves to the right 2 places, but it is decay, so it's going to come down like this. So again, looking at this, I can tell that my domain is all real numbers, and that my range, my x or my y values, is everything greater than 0. So what I'm going to ask you to be able to do is explain how the graph is going to shift. So keep in mind how the graph is going to shift. You're going to need to be able to say, because the b is less than 1, it is going to be a decay graph. Or because the b is greater than 1, it is going to be a growth graph. That's the first statement you would make. Then, the number with the x shifts in the opposite direction. So a negative shifts to the right, a positive shifts to the left. So a negative is going to shift the graph that number of places to the right or that number of places to the left. So this is going to shift it 2 places to the right. This one's going to shift it 1 place to the right. And this value, the k, our k is plus 0, shifts it up or down. So this is going to shift it up 2. Remember, it's the same. So with the x, it's opposite. With the y value, it would be, or here it's going to be the same. And it's going to be no vertical shift. And then based on that sketch of a graph, you can tell what the domain and ranges are. All right. Rewriting everything in exponential and logarithmic form. Remember, we have base, exponent, didn't want to write that, exponent, answer becomes the log of base, answer, exponent. So the base drops down, answer comes here, exponent to the end. So the base is 18, so this is going to be the log base 18 of, what's our answer? 324 is equal to, and what's our exponent? 2. So again, log, what's our base? Our base is 12. What's our answer? 144. What's our exponent? 2. Same thing here. We can look back at this and identify where is our base. Our base is 12. Where's our exponent? Our exponent is 2. And what is our answer? Our answer is 144. Our base is 3. Our exponent is 4. Our answer is 81. Okay. Sorry, I needed to get a drink. Find the inverse of each function. So we have to get the log on one side by itself. Let's start with 16 then. It's already that way. So the log's on one side by itself. So now we can use the log base answer equals exponent. Flip it around. So log base 10 so this becomes 10 to the answer, which is y. No, sorry, that's our 2x. Confusing myself. The base is 10. Answer is 2x. Here is the exponent. Looks really bad. Okay. Now it says find the inverse of each function. That means I need to flip-flop the x and the y. So we have 10x is equal to 2y. And then we can rewrite it in exponential form or log form, which is simply going to be the log of 2y is equal to x. And you can see, really, we did the long way for just flip-flopping x and y here. But see, we have to rewrite it in a way so that it's y equals, which is why this is a problem, because it doesn't say y equals here. So what I'm going to do is actually go back to this, divide both sides by 2, and then guess what? I do have it. So it is actually equal to y equals 10x divided by 2. That is the inverse function. Okay, so again, we get the log on one side by itself. So I'm going to move minus 5 to the other side. So we have y minus 5 is equal to the log of x. I then put it into exponential form. So 10, that's our base. This is our exponent to the y minus 5 is equal to x. Now I flip-flop my x and my y. So we have 10 x minus 5 equals y. And guess what? It now says y format, so this is our final answer. Okay. Skip that one. So the log graph, remember, is the inverse, which means you flip it across the line y equals x of the exponential graph. All it does is flip it across. So anything that you have shifted this way, it's going to shift the other way. Or let's just look at it in terms of the graphing calculator. So if I go to the natural log, that's what ln, natural log of x minus 1 plus 4. So go to our Desmos graphing calculator. We want it to be y equals the natural log ln of, what was it? X minus 1 plus 4. We have to make sure our parentheses are x minus 1, close our parentheses, plus 4. Okay. So when we look at this, our graph is reflected across the line y equals x over here. We can see that the domain is all x values. So the domain here is going to be everything that is greater than 1. So we can see that the shift, if we'd changed this, it would be on the 0. So we can see that this is going to be, again, the opposite. That by moving with the x, it moves at the opposite value. So opposite of x, or sorry, minus x is actually going to move it to the right. Positive x is going to move it down. Okay, so it moved everything to the right 1, and it moved it up 4. So you can see here's our 0, and it moved it up 4 places. So when we think of this with our graphing abilities, we know that, again, this is going to move our x to the right 1. It is going to move it up 4. So to the right 1. And here is our new vertical asymptote. And it moves our 0 to the right 4. Normally would be here, so now it's here. And so we have this graph kind of like this. We can see when we look at that the domain is going to be everything greater than, the x is going to be greater than 1, and the range is going to be all real numbers. And we can do that simply by understanding a quick sketch and what happens to the shift. So again, the number with the x is opposite, so it's going to shift everything to the right 1. It's going to have a vertical asymptote located at 1. It is going to shift it. This is the opposite. So remember when it was plus 4, that was up 4. This is negative 2, so it's going to be down 2. So we move our 0 down 2. And here's our quick sketch. So what do we have here? We have that our domain is going to be everything greater than 1, and our range is going to be all real numbers. Okay. For these, remember, we're working from the powers or the rules for exponents to kind of help us with this piece. So, and then we're also going to use our rule for converting logarithms, but this says expand, so we're going to rewrite it larger. Okay. When we raise a power to a power, that's what we're going to worry about first. We're going to kind of work this way. We actually multiply. So what do? We're going to bring this out front. So the first thing I can do is say that this is 3 log of 5 of a squared over b. Then I can divide. When I divide, what do? I subtract. So top always comes first. So this becomes 3, and I'm going to do parentheses because remember, order of operations matters. Log 5 of a squared minus log base 5 of b. Now, I still have this exponent to move out front, so I'm going to move this out front of here. Now, that is the reason why I put this inside of parentheses, because if I really want to get rid of those parentheses, I then am going to have to distribute. So we actually have log of, 3 times 2 log base 5 of a, oops, don't want that one, minus log base 5 of b. Then I can distribute my 3. So I could have 6 log base 5 of a minus 3 log base 5 of b. Or I can leave it like this, either way. Okay, so here we are multiplying, so what do? We add. So we have the log base 2 of u plus the log base 2 of v plus the log base 2 of w to the 6th. Now, we can't leave this because they're not all bases, or the answers are not simplified yet. So the 6 goes not out in front of all of them, but it only goes in front of this, the log 2 of w. So we have log base 2 of u plus the log base 2 of v plus 6 log base 2 of w. And that becomes your final answer. So again, this is multiplying. So we add. So this one becomes the log of x to the 4th plus the log of y to the 5th. The exponent then comes out front. So we have 4 log of x plus 5 log of y. Let's change this to a fraction exponent before we get any further. Instead of saying it's the 3rd root, this is going to be x to the 1/3. It's going to make our life way easier. So this becomes log base 3 of z to the 3rd. Because we're multiplying these two, we're going to be adding plus log base 3 of x to the 1/3. And then we just move our exponents out in front. So our final answer is 3. Log base 3 of z plus 1/3 log base 3 of x. Okay. Here is very similar. We're going to actually change this to 1/3 and 1/3 here. Because the number's out front, it becomes an exponent. So this becomes log base 6 of c plus log base 6 of a to the 1/3, and then plus log base 6 of b to the 1/3. Now because we're adding, we're going to multiply those 3, and because the logs are all the same, we can do this. So it becomes log base 6 of c times a to the 1/3 times b to the 1/3. Now because those have the same exponents, and remember 1/3 is a cube root, I would actually rewrite this as the log base 6 of c cube root of ab, personally. All right, so again, we move this to the exponent first. So we have the log 3 of a to the 4th minus log base 3 of b to the 8th. And then because we are subtracting, we are going to divide, and the logs are the same, so the log 3 of a to the 4th over b to the 8th. Again, all the logs are the same, which is good. The 4 becomes our exponent for our z, and because we are adding, we are actually going to multiply. So this final answer becomes log 2 of x, y, z to the 4th. Again, our front numbers become exponents. The logs are the same. Because we are subtracting, we are going to divide. This becomes log base 8 of u to the 6th divided by v to the 18th. Okay, change of base formula. Remember, this is simply going to be log of 2 divided by log of 44. Log of 7 divided by log of 69. Log of 7 divided by log of 1. That's it. Okay. I have just recently made the video on the solving the equations, so I'd like you to please go back and watch those videos for the solving equations. The answer choices will be included, but I want to kind of cut this off because I've been making this for about